So now you've heard a little bit about this nudge and smudge behavior change protocol that we developed earlier this year. I thought it might be interesting to take you through the scientific basis for why this is working, why this smudge is actually working. And when we say smudge, what we really mean is rational override. It's a point at which we stop trying to unconsciously nudge a person and we instead encourage them to reflect on their decision and why they made that decision in the first place. And we're going to talk about this a little bit later when it comes to case examples, so just stay tuned for that. But what I wanted to do is just take you through the science and the neuroscience in particular of why rational overrides work and why sometimes people can convince themselves that they performed a behavior for a reason that is not really the true reason behind that behavior. Because after all, what we want to do in this nudge and smudge protocol is we want to change people's behavior in some way. We want to nudge them. And at this point, you could leave it there and that would still be effective. But at this point, I think a really useful next step is to create this smudge, this enduring change in belief that accompanies this nudge that really makes it a whole lot more powerful and operates at a completely different level to just nudging alone. So let's take you through what a smudge really is. And like I said, it's all about post hoc rationalization. It's all about reflecting on the decision after the fact. And you might be thinking to yourself, well, this person made the decision in a case where they were nudged, but they will be aware in some way that you made the decision for them, that you influenced their behavior. But this is not actually always the case. In fact, a lot of the time when it comes to nudging, the behavior actually doesn't occur. The reasons for the behavior aren't exactly clear. So, for example, like just going back to the fly in the urinal example, I'm not sure how much you've heard about this, but at Schiphol airports in the Netherlands, they started by placing a fly on the urinal that allowed people to redirect their flow towards making it less of a mess when the cleaners had to come in and clean up later down the track. So this was a nudge. Quite clearly, it was a change in the environment that changed the behavior of the individual, and it was a very minor nudge. No one really was sitting there thinking, okay, I chose to pee in a clean fashion and in a try to reduce the amount of mess I make. People weren't thinking, yeah, I did that because someone put a fly there. If you asked them afterwards and you said, hey, like I notice you really are quite clean. Like the bathroom after you leave is actually, there's no splatter marks anywhere. Why is that? Their explanation's probably not going to be, well, it's because you put a fly there, otherwise it would have got all over the wall. Their explanation's going to be, hey, no, it's because I'm a clean person. It's just the way I am. I respect everyone else who has to use the bathroom after me. They will come up with an explanation. And I mean, that's a pretty specific example, but I think you'll find that a lot of the time when you nudge someone to perform a particular behavior, they will provide a different reason entirely. But let's get into the science of exactly how this is going to happen, because this actually might surprise you quite a lot. And to do this, we're going to be looking at a set of experiments called the interpreter experiment. So I'm going to take you through one experiment in particular that I find really fascinating. And essentially how these experiments worked was they used a participant pool of patients who had the corpus callosum, which is a region in the brain that runs right down the center of the two lobes of your brain. And this is the only connection that connects the two cortices on the top of your brain from left to right. So without this, if this was severed, if there was a lesion through this entire corpus callosum, there is no way for the cerebral cortex on the right side to communicate with the cerebral cortex on the left side, which means that the communication is impossible for a lot of things. And the reason that people had these severed was usually because they were epileptic patients who were having major seizures regularly, and by cutting this, it actually reduced the amount of seizures they have. And you might be thinking, you can't cut someone's brain in half and expect them to function normally, but actually, as it turns out, you can. And this is exactly what they did, because the sides of the brain tend to operate reasonably independently of one another. Anyway, long story short, this was the patient pool, and they realized that they could actually do something quite interesting with these patients and could discover something quite fundamental about the brain in doing so. So just a little bit of basic neuroscience or biology that you might need to know to understand this experiment. If something appears in your left visual field, so something appears over here, the left visual field being of either eye, so on this side of this eye and this side of this eye, so everything I see in my left visual field, all that information gets transferred through the optic nerve before it even gets into the brain to my right visual field, to my right side of my cerebral cortex. So all the information over here is being transferred to this side of my brain, and all the information over here is being transferred to the other side of my brain. And if there's a lesion down the middle, then it's staying on that side. Okay, that's the basics. What the researchers did is they quickly flashed something so that it would only appear in the left visual field of the patients. And in this case, it was a little prompt that said the words "stand up." So it was a call to action that basically said, "Stand up now." And then, of course, dutifully, the patients would stand up in response to seeing this prompt, and, this would all be happening on the right side of their cerebral lobe. So they stood up, as you would expect, and then the researchers turned around to the patient and said, "Why did you stand up?" And here's the interesting part, because actually on the other side of the brain is where the interpreter is located. And I mean, the interpreter is just a general concept we use, but it's essentially a particular brain region where the interpretation of events occurs. So if you ask someone, "Why did you do something?" and they need to come up with an explanation, they need to rationalize that. It's going to happen on this side of the brain right here, approximately. And essentially, they would ask these people, why did you stand up? Why did you make that decision? And their interpreter, being not connected to the actual source of the information, the actual reason, which was the sign, would say, "Oh, I stood up because I wanted to go get a Coke from the vending machine," or, "My legs were really stiff, so that's why I stood up." And that would be the reason they would provide, and that would be the reason that they would believe. And the experimenter, of course, is sitting there like, "What's going on? I just told you to stand up, but I told the other side of the brain, and now you're acting as if you were performing this behavior for some completely different reason that was definitely not the real reason why you performed the behavior." That's an interesting case study, and I think it actually demonstrates something quite profound about how we think about the world and how we explain our decisions while we're looking backwards. So essentially what this tells me, and what the researchers also concluded, is that people will always provide an explanation for their behavior, even if they don't know what the explanation is. And as we were talking about earlier, oftentimes when it comes to nudging, we don't actually know what the explanation for our behavior is. If you nudge someone and then you ask them to explain it, they will often just give you a completely different reason than the actual reason why they perform the behavior, and they'll believe it. They'll really believe it because they have to have an explanation for that behavior, or else it doesn't make sense why they did it in the first place. So, if you can nudge people's behavior, then the next step, if you want to create this cycle of, you want to create this smudge and continue this cycle of behavior change, essentially all you have to do is find a way to get people to explain their behavior. And I mean, classic examples of this might be through some sort of recruit a friend transaction where, for example, you sell something to a client and then you invite them to partake in a recruit a friend transaction where you say, "Okay, well, you obviously like our product. Why don't you try to, so like if you can convince one friend to buy a product, then we will give you 50% off your next purchase." And then, of course, this person is forced to find a way to convince their friend why they should buy this product. So they will then come up with an explanation in their own mind for why they purchased that product. Maybe you nudged them, maybe you used a discount, maybe you did any number of things to make them buy that product, but now they're going to come up with another explanation. It's going to be because it's just the best quality product and they're just a really fantastic brand, and then they will justify in their mind, provide an explanation for this behavior, a post hoc rationalization, just like our split brain patients were doing with the vending machine. And then that will become the reason why they purchased that item in the first place, why they chose your brand in the first place. And if you can get customers to do this, you can change a customer who was just a one-time user who bought one product because you nudge them into a customer who is now loyal to your brand. And this is, of course, just a conceptual model. This isn't something that we drew from other research. This is something we developed on our own. But I think it does quite a good job of explaining why people often act in irrational ways when making decisions. And it's a great way for you as a company to start influencing the behavior of your clients.